Now we are going to look at certain examples related to fluid force. So these problems are example problems of within the book. A rectangular plate shown in vertical section AB right here is 4 meter high and 6 meter wide. The height is 4 meter, and the depth, that is something going to the screen, is of 6 meter. Now a channel 3 meter deep, uh, wide, and blocks the end of the freshwater channel 6 meter deep. The plate is hinged about the horizontal axis along its upper edge through A and is restrained from opening by a fixed rigid B which bears horizontal, you know, against the lower edge of the plate. Find the force B exerts on the plate by the ridge. It's very, very simple and easy question. So how do you solve this thing? It's very simple. You need to find rho GH. This is the maximum volume. This volume is applying force right here. So you need to find how much is this volume. You said H is 3 meters. So you got rho, you got G, and you got H. This is amount of pressure this water is applying on this ridge. Okay? So what you need to find is, this is how your pressure distribution would be. This is exactly amount of resultant R force will be acting on it. Amount of action reaction, simply force. So let's see. A pin joint will have two forces, that is something acting on x-axis, something acting on y-axis. Since we are going to talk about moment about A, so these forces will eliminate, you don't need to go there, but we are drawing free body diagram. Then we have a reaction or resultant force of the triangle pressure. At this point the pressure is 0, but here you have the maximum pressure, so go to edge. This is the maximum pressure. It forms a triangle, and right at 1/3 of the distance is the center where resultant R is going to work, as shown right here. Now, assuming the drawer has a negligible weight, so you need to find the reaction B. If you look at this thing and you say this is point A, this is R, this is B, so you can talk about the moment of R that creates rotation about this, and moment due to B, they should be equal and opposite. And there you can find the value of P right here. Here's found the value of P average, that is from the resultant R, you can say. And the moment generated about A is equal to 0, so this is times 3 times R, 4 times B, will give you the value of B. A very, very simple approach. Now let's look at another problem. The air space in a closed freshwater tank is maintained at a pressure of 0.8 pound per inch squared. This is the pressure inside the airspace, airspace inside the closed vessel of water. Determine the resultant force R exerted by the air and water on end of the tank. Right here, at the end of the tank. So what he has given you, he has provided you the pressure of the air inside the tank. Right? So this is the tank where the pressure is right here. This air is applying a specific pressure on the surface of the water. This means you have initial P0 or P1. Now you have to find the value P right here, that is rho GH. Now here you have to remember P0 is given. What you will find is rho plus P0. You have to add this value to the actual pressure depth. So this is your R1, add rho 1 right here. This is the static pressure that you have already inside the due to the air. And then you have to find the value of R2. R2 is the pressure of the triangle. This triangle is formed based on the pressure variation as you go deep into the water. So this is P average, that is 1.8 rho GH. H is varying 30 inches, so you get 2 P's divided by 2, and this is what you got R2, and this is where you got R1. Right? Now how did you find the R1? This is again, you got the pressure and the force per unit area gives you pressure. So you got the value of pressure multiplied by area, you will get resultant R. So what is the area? As you all know, 25 inches by what's the depth? This entire length. So he has given you this area. This entire depth is in fact 38 inches. 25 by 38 will give you area. 0.8 pound atmospheric pressure, 38 width, and that is the end view and the side view. You get the R1, and then P average. P average, as you know, from the point the water is in contact starts to the depth of 30 inches, 2 P's, and then you got the area again, the area under pressure. The height is 30 inches times 25, triangle 30 by 25, and this is going to give you the half times this thing is going to give you the area of a triangle, and you get the reaction R2. We have the two R2, so we need to find the average R. Where does it exist? The overall R should be the resultant of this thing, but at what height should it exist? So you have 19, that is because it is going to be the center based on this point and this point for the air, and for 28 it should be the same center but at 1/3 of this height from the base. And what you will get in the two different heights, right in the center of the two heights will exist your resultant R. And this is where he has calculated the moment based on this thing, moment based on the pressure of the atmosphere, and moment due to the pressure of water, clockwise and counterclockwise, and you'll find right in the position between 19 and 28. Simple as that. If it seems difficult, since the deliverances in English might seem difficult for some students, you can always ask me afterwards. I can help you understand. It's easy to understand Urdu because it is our language. But due to the certain requirements of the HEC, we have to deliver these lectures in English. So if you have a problem, please feel free to contact me. Now, let us look at the last problem. Determine completely the resultant force exerted on the cylindrical dam surface of water. The density of fresh water is 1 megagrams per meter cube, and the dam has the wavelength of B, normal to the paper of 30 meter. B is 30 meters, normal to this paper. This means normal to the surface. 1 megagrams means everybody know 1000 kilograms per meter cube is the average density of water. This is fresh water, so we need to find the resultant R. You are going to use the same technique of surface, curved surface. How you find it? Number one, you have to find the pressure based on x-axis as the pressure as you move. Let us draw this Cartesian. This is suppose your x direction. This is your y direction. You should remember as you go down from top to bottom, the pressure increases. As the pressure increases, it will form a triangle region. You remember this thing. And when you draw this force region, you know the reaction x this way due to the resultant. And this is going to be the cross-section area. What is the area? 4 meter by 30 meter. And this will provide you just the position along y-axis, that is y prime. Now you need to find x prime, where exactly the px exists, and you are going to take this volume right in the center. It will provide you the center of gravity, and based on this center of gravity you will get the weight of the water acting downwards. Since if you look about this thing, if you move along x-axis, there is no pressure variation. The pressure is constant no matter what value of x you take. Throughout this position y, the pressure will be constant along x-axis. What you need to know is where the gravitation of this, the center of the mass exists for this particular volume. And you have found simple through the 1/4 of circle, as you know, the volume of the circle and where it exists. Based on this information, you can use Pythagorean theorem and find the exact value where this y and this x exists, and you can find the combined reaction R. Once you have found those things, this is what is required where exactly this force is acting. Now this is one thing. The second approach is you have studied it. You are going to integrate to find the shaded region or area under this curve, and using this substitution, we are going to find the exact value of R and the position of R. Similarly, you can have determined, you can look at this one more example. Determine the resultant force R exerted on the semicircular end of the water tank shown in the figure. If the tank is filled to capacity, express the result in terms of R and water density. I think this has both the features of the circular region, a cylindrical surface, and you can find the value of R as you know as you move down from the triangular region, and you can find this value very easily. My suggestion is this you do it yourself. If you see any problem, do contact me, and I will put some solved numericals. Hopefully, those lectures would be in the native language. Inshallah, it won't be difficult for the students to follow through.